I'm going to go through one more hypothesis test. I decided to split this last video into two parts just for time purposes. But in this second hypothesis test, it says 11 high school students took an SAT math prep class. They had already taken the SAT before and recorded their math portion scores. They attended the SAT math prep class once a week for 5 weeks, and then after the class ended, they took the SAT the following week and recorded their math portion scores when they received the results. The data below here provide the differences of math scores after the prep class minus the math score before the prep class. Treat these students as a random sample of high school students and perform a hypothesis test to determine whether the mean SAT math score increased after taking the prep class. We're going to determine if the mean is positive. Assume the conditions for a t-test are met and use a significance level of 0.05. So we're going to go through a hypothesis test on the t-distribution. We're looking at means here. My data is showing some students improved. The first student improved their math score by 10 points, the second by 26 points, the third student by 38 points, but not everybody improved. This student had their math score decreased by 12, another had a decrease of 21 points, 16, 31, and 5 as well. So it's not proven that this prep class will actually improve your score for everybody, but when you see does the mean, does the average show an improvement? For my hypotheses, my HO and my HA, HO will be mu is equal to 0, and HA will be mu is greater than 0. Again, the null assumes equality, so it assumes that the score will be equal before the math class and after the math class. So if it's the same before and after, and if you subtract them like it says here, it's the math score after the prep class minus the score before. So if they're the same, if you had a 600 before and a 600 after, 600 minus 600 would be 0, no improvement. Or if you had a 480 and a 480, they're the same for both, you subtract and you would get 0. Now we want to see whether the mean math score increased. So it went up, it's greater than what it was. So these are my two hypotheses. For my test statistic, that's going to be a t. And my p-value, I'm going to go to my calculator. Once again, that's stat tests number 2. The t-test is the hypothesis test for means. Once again, I have the raw data. I need to put that into L1, so I hit stat, edit, and to save some time, I've already have it entered into L1. So I can go back to stat tests number 2. My mu sub O can stay 0 because that's what I set mu equal to in HO. My data is in L1, the frequency is 1, and I need to change that symbol from a not equal to a greater than. This symbol comes from my alternative symbol, and I just hit calculate. So my t is 0.73. If I round that to 2 places, and my p-value is 0.2425. So what is my decision regarding the null, reject or not reject? This p-value of 0.2425 is greater than 0.05. When that's the case, I do not reject HO. And so what this means in the context, these scores do not show the students improved their math scores. Those that improved were balanced out by those that regressed, who didn't do any better on the exam. So I can't support this idea that the mean math SAT score went up. It appears that's not the case. So I do not reject HO.